So the topic tonight is doing Power BI the right way, specifically for database developers. So we're going to talk about two different mindsets and two different disciplines that traditionally have really been kind of two different ways of approaching the way that we craft and shape and utilize data. That being the world of the DBA or database developer and the world of the BI practitioner. I'm originally from Vancouver, Washington, which is where I am now, but have moved around a little bit. Pragmatic Works, a little over 2 years ago, was acquired by 3 Cloud Solutions, which is the company that I work for today. My wife and I, after the kids have all moved out, we wanted a little bit of an adventure, so we did something kind of crazy. Last year, we sold the house, we bought a Class A RV, and we went on the road. And I've been working full-time on the road for about a year now. And I continue to blog in my technical blog, SQLServerBI.blog, also blog about our experiences on the road, particularly as I have been able to meet with and interview leaders within the data community at dataontheroad.blog. So enough about me, let's move on, but you're welcome to follow me. So this is what we're going to talk about. So let's start by talking a little bit about Power BI. What is a typical Power BI use case? What do most people use Power BI for? Well, typically a tool like Power BI is seen as a self-service or ad hoc data analysis tool. And so it's used for ad hoc analysis, quick, go connect, import something, start analyzing and visualizing that data so that we can make business decisions and better understand something that's important to me as a business user. It's for quick reporting. We transform data, we shape it as we go, we can craft it on the fly, spend an afternoon importing, shaping some data, visualizing it, and then we're done. Data modeling, it's an evolutionary process. Import some more data, doesn't quite fit, mash it up a little bit, do whatever we need to do, clean it up very quickly on the fly. Visualizing that data, try and see, try it in a bar chart. That doesn't work, try it in a pie chart. That doesn't work, put it in a table, put it in a matrix, drill down, drill through. But in this evolutionary process, this kind of quick and dirty ad hoc analysis process, the things that we typically don't really pay attention to or really care too much about are standards, naming conventions, modeling and relationships, things like primary keys and foreign keys, strictly adhering to dimensional modeling rules. Measure logic, again, we're going to code, try and see, do a little bit of trial and error, and we end up with maybe a little bit of spaghetti code that we may or may not throw away or might keep around. Documentation, who needs documentation? Version control, what's that? And so this is the typical scenario. This is at least the 75% use case for Power BI. But then if we shift gears and think about using a tool like Power BI in an enterprise environment, well, the first thing that we need to do is we need to work with data professionals. Well, what do data professionals think about? Well, if we look at the database development discipline, so those of you who work with relational databases, who manage data and centrally manage data for the purpose of making it available to large audiences, to enterprise customers, data quality is enforced in the database. The database is the single version of truth, to quote Ralph Kimball. We try to avoid making copies of data silos. We want to discourage users from putting data in Excel spreadsheets and keeping them on our desktops. We maintain version control. We implement development operations or DevOps. We have gated and staged build and deployment processes, separating our dev environment from our test or QA environment from our production environments. We want to script and automate everything. And things like naming conventions, yeah, we've got rules around those things. And we traditionally use things like Pascal case or camel case, or, if you go way back into programming, things like Hungarian notation. So if you're a data professional, things like this resonate. These are your values. These are the things that you care about because they enforce rules and they provide order around our regimen in the way that we work with data. So we see these two worlds that are kind of colliding now. So we've got the BI professional who have largely been seen as kind of the loose cannon of the community. We don't adhere to rules because we just want to get things done. And then the DBA, they have to kind of rule with an iron fist and decide who gets to do what. So we need to back up a little bit and think about where the balance is between these two disciplines and where we can meet in the middle to collaboratively solve problems. So let's start with our audience, size and scale. When we think about size and scale, that could apply to the audience, the number of users, kind of the roles of those users. We can also think about the size and scale of our data. How much data, where does it come from, what is it used for? One size doesn't always fit all. With planning, informal projects, those ad hoc projects, can be adapted to meet enterprise needs or might serve as proofs of concept to help us build more durable, enterprise scale BI solutions. So the trick is to know when to keep and to update a design or when to toss it and start all over again. We'll talk about that just a little bit. So how do you plan for scale? So when we look at the Power BI licensing options, the different ways that you can utilize Power BI, first of all, I can go to powerbi.com, download Power BI Desktop, set up an account for myself, and it doesn't cost me a thing. Okay, so Power BI is literally free if I'm the only user. And I can publish that out to my tenant, and then I can go there and I can view reports. I could use the publish to web feature, and again, I could share a report with the world, and it doesn't cost me a thing until I need to share that in a secure way. And to do that, I need a Power BI Pro license. And that's going to cost me retail. There's all kinds of discounts, and we're always trying to be real careful about quoting Microsoft licensing prices, but the retail price of a Power BI Pro license is $10 per user per month. So if I want to share reports securely with a small group of people, I can import data into a model, and that data is compressed inside that model, inside that PBIX file, and I can publish out a PBIX file, data model and report that is up to 1 gigabyte in size using a Power BI Pro license. And then every user that I share that with needs to have a license. Well, then we can move up to premium. Now, the transition from Pro to premium used to be a pretty steep hill to climb. Now, with a premium license, and we can start with a P1 license, which the retail cost is $5,000 per user per month, which is paid annually. That's pretty steep, but I can share that with an unlimited number of users within my organization. So that's great for enterprise customers. And if you have, 350, 400-ish customers, do the math, and premium can be the more affordable option. But now Microsoft has given us another option, and that is premium per user, which means I get a whole bunch of premium features at a cost of about $20 per user per month. So again, it's just a mathematical equation. Well, with premium capacity, which includes premium per user, there are all kinds of enterprise features, and I'm going to be demonstrating some of those features for you tonight. So I don't want to get into the weeds with licensing, but I wanted to bring this up as just kind of a statement that though Power BI is a great ad hoc tool and it's inexpensive to get started using it and to use it in a secure manner with a smaller group of people, there is certainly a grow-up story and an enterprise story around Power BI as evidenced by their licensing model. All right, let's move on. Is Power BI enterprise ready? Well, let's look at the evidence. So what are the questions that we would ask to determine whether a product like Power BI is enterprise ready? Well, can it handle large scale data? Well, with Premium, you can have data sets that are several hundred gigabytes in size, keeping in mind that this is compressed data and it's data specifically used for analytic reporting. So you certainly don't want to import an entire data warehouse into a data model with all of the transactional details. So we can handle a lot of data, and we can do some creative things with direct query, hybrid composite models to get the best of both worlds, not necessarily import all of that data. So check that box. We can certainly handle large scale data. Can we serve up reports for thousands, tens of thousands of users? Absolutely. Premium capacity gives us the ability to do that without having to license each of those users individually. We can certainly handle the capacity. What about team development and collaboration? This has been a big challenge in the past with Power BI because it was built to be a self-service analytics tool first, but it's built on top of enterprise scale technologies like SQL Server Analysis Services, Power Query, which kind of has its roots in tools like SSIS, etc. Can we implement data governance policies? Absolutely. What about data management policies? Yes, Power BI can certainly be used in concert with enterprise thinking, the way that we think about managing enterprise data. Lifecycle deployment, we're going to talk about all of these things. Versioning, challenging, but yes, absolutely can be done. Can you embed Power BI reports, visuals, dashboards into a custom application, into an enterprise portal, into an external facing application? Absolutely. We have tools and technologies that allow us to do that. It can be automated. There's a great administration story. So for more just on the enterprise readiness of Power BI, two resources that I would point you to. One is the Power BI Enterprise Deployment White Paper, which has actually been around for a few years now, gets updated every couple of years, primarily written by Melissa Coates, who is a well-known expert in this space. And Microsoft just a few months ago stood up what they call the Power BI Enterprise Hub, which is a collection of all of their white papers and documentations specifically around the Power BI Enterprise story. So yes, Power BI is absolutely enterprise ready, though I think a lot of users and customers think of Power BI as an ad hoc and self-service tool. And that's because there are so many people who use it that way. Okay. Another concept that I think that is important as we shift from self-service to enterprise BI thinking is this idea of certified and shared data sets. If you're in ad hoc mode, you know, I've just installed Power BI Desktop, I'm just getting started with it, I'm going to go connect to some data sources, import some Excel files and CSV files, maybe connect to a database, import that data, visualize it, maybe write some DAX, a couple of measures, everything's contained in a PBIX file. And that suggests that it's this monolithic thing. However, when you deploy, the data model and the report are actually two separate objects. And just here momentarily, I'm going to talk about how we can separate them and actually treat them as different objects. But that data model, which is called a data set after it's been deployed, can be endorsed, promoted, and certified so that it can be managed in concert with organizational data governance policies. So by using endorsements, we can kind of separate the self-service models. That's the untrusted or the semi-trusted, you know, sandbox models, the things that users have created just as they're playing with data and using it for their own analytic purposes, from those enterprise scale models that have gone through rigorous testing, QA review, and perhaps we have a data governance committee within our organization who have some very rigorous rules for deciding whether or not data should be trusted or not. Then that group can then certify that data set to say, all right, these certified data sets over here are fully trusted. That's a single version of the truth, and that's where you should go for trustworthy reporting. All right, so how do we future-proof Power BI solutions? Well, the challenge here is it's difficult to see the future. It's difficult to know what our requirements are going to be. And I would say that business intelligence is kind of the amplified example. It's the most extreme example of changing requirements and scope creep and all of those moving parts that are always going to change and difficult to predict. So I did a blog post that actually kind of evolved into a series of blog posts on this topic. So if you go to my blog at SQL Server BI blog, which I'll have a slide at the end of this presentation, I'll also show you where you can go to download a copy of this presentation so that you have all of these references. On doing Power BI the right way, and particularly the first article in this series of I think 14 posts so far, future-proofing Power BI, and that really kind of set the groundwork for this presentation. So here's the reality of BI projects. You will never, ever, 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 ever have all the requirements defined ahead of time. That is just reality. Now, if you went into an app dev project and at the get-go said, you know what, we just don't know what the requirements are. Let's just start coding and we'll add features as we go and hope it works out. You probably wouldn't have a job. And as a consultant, we just probably wouldn't be in a very good position with our clients. But this is a harsh reality of BI. Now, can we define the requirements and scope them well enough to define a project? You betcha. But you're just realize that you're swimming against the current just a little bit because things are going to change as that project moves forward. I call this the Columbo effect. I have a client in particular who I'm thinking of right now, who at the end of every meeting would always end by saying, oh, wait, there's just one more thing. There's just one more thing that I need. I see Mark smiling because we've all experienced this. This is what happens in BI probably more than any other type of project I can think of. You put a cool report in front of somebody. They go, oh yeah, all right, great. I see where I get some insight there. I see where now I understand, you know, my underselling products or, you know, my highest performers. But if you can do that, then can you do just this one more thing? Can I drill through and see more detail? Can I, you know, understand this or slice it differently? So that brings us to the tenets of iterative design. Now we live in a very agile world now in a lot of different ways. And so that's really what we're talking about is being agile and taking an iterative approach. The realities of taking an iterative approach are, one, we start by defining our solution scope. So what's in the box, what's out of the box? What are we going to do? What are we not going to do? Then we work in iterative cycles to you know, harden those features inside the box. And so we end up with this iterative model with, you know, little iterations that contribute to the larger iteration. And in that process, we're going to evaluate our design to the solution scope, you know, the SOW. We're going to keep what works. And here's the hard part. Throw away the stuff that doesn't. So it's tough to spend hours on end building something and then hit a dead end and realize that that wasn't the right approach, learn from it, realize that there's value in the process, and then throw away the stuff that doesn't work, repeat the cycle, and continue to keep what does work, learn and improve. So we have to take the bad news with the good news, and you know, we're all better off because we've learned. And then we want to evaluate to the solution scope and realize that, hey, gosh, we added a feature and it wasn't in the SOW. So we need to rationalize that. We need to go back and say, hey, you know, you asked for this thing that we ended up delivering that we hadn't talked about it initially. Do you want to keep that? Do we want to, you know, realize that there are requirements around that? Okay, so let's talk about how to make this actually work. So I have a number of topics where we're kind of going to look at the database developer's perspective versus the BI solution designer's perspective. So how do I manage project files? Now, depending on the type of project, these project files might, it could be SQL scripts, object create scripts, it could be app dev code. With respect to BI, it's going to be our queries, it's going to be our model design, our measures, our DAX code, and the files where we keep our reports. So database developer, use a source code repository. That's paramount. We're always going to protect our code. We're going to put it in a shared repo where it's backed up, we've got disaster recovery, it's versionable, etc. We want version control to be automated. We want to manage everything in script. We want to automate and build our deployments. So there's a lot of rigor around that. So that's the way the database developer thinks. Now, turn to our BI solution designer. It's all about getting to visualization quickly, getting to an analytic capability quickly. So yeah, I might keep my PBIX files in a shared file folder. By default, they're just going to be in my documents folder, but yeah, it's convenient to use OneDrive. So I guess I could do that there. Version control, I'll postfix my file names. If I go add some feature that I'm experimenting with, I'll go make another copy of my file. And, and then how do you reconcile the two? I don't know, that's kind of a manual process. We're going to go through iterative design steps, and we're going to deploy directly from our desktop. No automation, no script, no build process. So the balancing act between these two approaches is, first of all, understand that there are realities to the reason that BI is iterative and a bit ad hoc. Realize that that's part of the process. So the balance may be that we need to use shared storage of some kind. If that's OneDrive or Dropbox, so be it. It's easy. OneDrive, because it's based on SharePoint Online, has rudimentary version control. It's not as sophisticated as a true repo, but you can roll back to an earlier version. There just isn't as much discipline around it. In a more disciplined project, in a more formal project, you can create a GitHub repo or an Azure DevOps repo and keep your files there. And I'll talk about where that can be challenging, and I'll show you how to work with that. So managing Power BI desktop files. So the thing that I do want to point out here is that in its natural state, if you import a boatload of data and let's say you've got 5 years worth of sales data or inventory data that you need to analyze, you're going to create PBIX files that are, hundreds of gigabytes in size. So let's say you have a 600 megabyte file and you drop that into a GitHub repo and then you version it every couple of days. That's not going to be a good experience. Okay, you can't manage files that size in a regular repo. So how do we maintain that? How do we tame that? And so let's just note that that's a problem that needs to be solved, and I'll show you techniques for keeping your file size small so that you have manageable and versionable Power BI desktop files. Okay, connecting to data sources. So let's say that I have a set of reporting requirements, and the stakeholder says, well, I want to see aggregate sales by region, by date and month and year, and by territory. And a database developer would think, oh, well, I'm going to write some SQL to do that. All right, I'm going to select from these different tables. I'm going to join these tables together with outer joins. I'm going to do a group by, I'm going to do an order by, I'm going to use sums, I'm going to build a big SQL statement to do that because that would meet those particular reporting requirements. All of those queries would be processed in the database. We would have real-time connectivity because I want to keep all of my data in my database and not promote making copies of that data. However, the BI solution designer is going to import that data into a data model where it can be managed there. And we want to perform calculations in memory within the model rather than pushing everything back to the database. So here we have a little bit of a collision of ideals. So rather than writing SQL statements, if you do need to join some tables together or do some inline transformation, rather than writing inline SQL, use views. So if the data is not in the right shape and it can be crafted using SQL statements, materialize that as a view, and then you can use those views to import from. There's a concept in Power BI called query folding that's very important to understand. And particularly when you're using data at enterprise scale, it is absolutely imperative that your largest tables support query folding. And this is going to be a good place to drop off and get into a demo. With respect to, do I import that data into the model, or do I use direct query and leave the data in the database and then just create a metadata model? Import first. So that's where you're going to get the best performance. You're going to get the most functionality and the most flexibility. Direct query is a great feature to use when you have a specific requirement that calls for having a direct connection to source data rather than importing a copy of that and caching it in your model. All right, so let's talk about that. I'll finish this slide and then we'll start looking at some demonstrations. With respect to where you go to transform your data in Power BI, you really have three options categorically. One is that you use Power Query, which is the tool within Power BI desktop. So you can use drag and drop options and menu options that assemble these queries, that create transformation steps. Behind the scenes, it actually writes in a scripting language called M, or the Microsoft Data Mashup language. In Power Query can work very, very well with smaller and medium-sized data sets, can be used with larger data sets if you're very cautious about not performing very heavy transformations like pivots and transpose, maybe merge. Those operations can be very expensive and sometimes may not work with millions or billions of rows of data. We also have a web-based or a service-based version of Power Query called data flows. And data flows are a great choice if the data isn't already in a data warehouse or a data mart. That's not to say that data flows don't have some utility outside of managing your data centrally in a data warehouse, but there is some redundancy there. So I tend to use data flows when the data is not already crafted in fact and dimension tables that can be shared and used across different data models. And then finally, we can use a more conventional approach where we do our data transformation in an SSIS package, kind of old school, or if we're completely in the cloud, use Azure Data Factory or Databricks to do our transformations, and then stage and then transform that data into a star schema within a data mart or a data warehouse. And then we can just consume that very, very simply using Power Query. So let me jump over to an example, and we'll talk a little bit about these options. So here in Power BI Desktop, wrong file. Get all this opened up, and we're going to use this one. All right, and I'm going to jump over into Power Query and talk just a little bit about this idea of query folding. So if you're experienced with Power BI, you may be familiar with what query folding is. If not, I would say that this should be on your top 5 lists of things to understand when working with enterprise data in Power BI. So I'm going to go down and take a look at one of my fact tables. So the fact table is a table that contains numeric values that I want to aggregate. And typically, I'm just going to have keys that are used to relate this table to my dimension tables. So just kind of going back to old school dimensional modeling, a la the Kimball method, the data warehouse toolkit. Those rules, those ideas haven't changed. They're just as true as they used to be. So this is a fact table. And store sales table may have tens of millions of rows. So you can see here that I'm connecting to a SQL Server instance. I'm using Azure SQL, but I've used parameters to manage both the instance name and the database name. So if you go over here to my parameters, you can see that I have a parameter called SQL instance name. There's its current value. It just points to my Azure SQL instance. And there's my database name, which I've parameterized. And you can see that I actually have two copies of my database up in Azure SQL. This is my dev instance, and then I have a production instance. In a larger environment, I may have three environments. I may have a dev, a test, and a production instance. And I'm going to use parameters to manage those things so that I can change them if need be. And I'll show you where I've done that. Let's go back to my store sales table again. So you can see that I'm now connecting to my instance and my database. And here I'm navigating to an object called store sales. And I'm not going to make any excuses for having an object with a space in the name in a SQL Server database. It's not what I would have designed, but this is Microsoft's demo data, and this is what they decided to do. It's not wrong, it's just not a standard convention. But this is the name of a view. And so somebody has written some SQL code that may have some inline transformations and has crafted my store sales data a little bit. And rather than when importing from an inline SQL statement and pasting that SQL statement here in my query within Power Query, I'm going to point to that view. And what does that give me? What does that do? Well, as we work down through the transformations, what we should see is if I right click, you can view the native query. So here you can see that I've performed some transformation steps, 4 of them so far. If I go down and view the native query, that those steps get translated into the language of my native data source. And so since I'm connected to Azure SQL, this gets translated into T-SQL. So here you can see the result of one of my transformations where I'm deriving some date logic. So let's just keep working down the stack. If I go down to the bottom, I right click, ooh, there I've broken query folding. That wasn't supposed to be in my demo. Yeah, so I've broken query folding at one point, which is something I would want to avoid. Now it's very possible that Power Query hasn't caught up and hasn't fully evaluated all my transformation steps yet. But this is how you can tell whether or not query folding is supported. What this tells me is that up to a certain number of steps in my query folding is working. There's the step where I apparently have broken query folding. Like I said, this wasn't intended to be part of my demo to show you that I've actually broken my own rules. But it's possible since I switched the data source that it just hasn't been able to evaluate that yet. So that's the concept of query folding. So let me jump back. Okay, I'm just going to leave this slide for reference, but as you're using Power Query, there is kind of an order of steps that I want to perform. Step number 1, use parameters to keep track of anything that might be variable. In my example, the database instance or the SQL instance and the database name, I wanted to parameterize. Use objects that support query folding. Again, using a view supports query folding. Writing an inline SQL statement, pasting a select clause with joins into Power Query will break query folding out of the box. The next thing I want to do is I want to manage the size of the data that ends up in the PBIX file on my desktop by using a date range filter. And I'm going to go demonstrate this. Then I'm going to remove all of the unneeded columns. And so as a database developer, I would tend to think, I'm going to look at a table that has 60 columns. And as I'm looking at my reporting requirements, there really only calls for using 10 of those columns. As I look at some of the other columns, kind of my natural thought process is, well, that might be useful in the future. Why don't I just leave it for now? And that's poison. That can inflate the size of your model. It can slow things down and can be hard to manage. And so get rid of anything that you don't absolutely need. You can always go back and add columns later on. Rename everything to use friendly names. Change data type so that everything makes sense and that every single column has the right data type, apply transformations, etc. Okay. So here's the hard pill to swallow. SQL isn't always the answer. So if you're a relational database person, it's hard not to think about solving problems with SQL. Use SQL where it makes sense, a la create views, and also leverage the features of Power Query where that makes sense. Use them together rather than just using one tool to solve all problems. So got a couple of slides like this, just things to bring to the top of your list of things to always remember. Transform your data upstream as far as possible and downstream as much as necessary. I just quoted a friend of mine, Matthew Roach, who's on the Power BI customer advisory team. This was kind of his mantra. Every Saturday morning, the guys from Guy in a Cube, Adam Saxton, Patrick LeBlanc, do a live stream. Matthew's one of the moderators, and he's often quoted. The question often comes up, hey, I need to shape some data this way. Should I do it in the data warehouse? Should I do it in Power Query? Should I use a data flow? Should I do it in an ETL package? And this is often the right answer. Do it as far upstream as possible so that the data actually exists in a state where that data has been transformed and can be used for reporting. But you don't always have the luxury of doing that. So as far downstream as necessary. Object names. Database developers tend to use short cryptic names because the audience of a relational database is typically an application developer. All right, people who speak tech. So they use code-friendly names, often cryptic names, short names. We use standards like Pascal case, camel case, etc. Whereas the BI solution is consumed by humans. It's consumed by real people, business people. They're not developers. They're scared by code-friendly names. They're scared by cryptic things. So we want to use friendly names. So the balancing act here is that any object in your data model that will be exposed to users, anything in the field list that you can pick from to create your own report, table names, hierarchies, column names, measure names should be friendly names. They should make sense. They should be as much as possible self-describing. And then hide key columns. Hide the utility columns like, the column that you use to sort the months, or anything else that isn't there for a user to see. Hide those things in your model. I'm a big proponent of creating explicit measures for anything that you want to report on, any numeric values. I would create a measure for that and hide the underlying numeric columns. It's more work, but it's a much cleaner model. It gives you more control. All right, so remember this one thing, quoting Jack Palance, name objects for usability. Again, a semantic model, a tabular model that you create with Power BI exists for the sake of users creating reports. It should be friendly, inviting, and self-describing. There's nothing wrong with spaces. There's nothing wrong with sentence case, mixed, capitals, spaces. There's nothing wrong with using pound signs and underscores and dollar signs and things like that. It's not going to break anything. Okay, model design. Database developer tends to think in terms of writing SQL queries that bring everything into a flattened table. When we write joins, that's what we're doing. We're taking, let's say, 4 different tables, joining them together, creating a wider result set. That's a flattened result. And that's great if we're just trying to solve one set of reporting requirements. And it's something that we might do using an old school tool like SQL Server Reporting Services, for example. We would flatten the results into a single data set, transform that data either in SQL or using an ETL tool, etc. Pre-aggregating results. Typically, when I sit down with a database developer on a BI project, and the report requirements are, I need the sum of this by geography, by month, by whatever, they'll say, oh, we'll store it in the table like that. We'll store it at the month level or at the country level because that's what our requirements say. But as soon as the user says, well, that's great that it's at the month level, now I would like to see it weekly or daily. You can't do that if you've pre-aggregated the result, if you've stored it pre-summed. We can handle tens of millions, hundreds of millions, even billions of rows of fact data if the model is designed correctly. So don't do that. Don't do that unnecessarily. And again, rely on import mode rather than direct query mode. Okay, so there's your balance. Build dimensional star schemas. So many times the answer to a challenging or complex BI problem is don't write hundreds of lines of DAX, build a star schema. All right, have dimension tables and fact tables, and utilize the model. Like I said, the tenets of dimensional design and dimensional modeling have not changed in 30 years. They're as true as they've ever been. There are newer books and newer examples of how to model using fact and dimension tables than some of the books like the Data Warehouse Toolkit, but the rules haven't changed. I mean, the physics of data haven't changed. So avoid wide tables. It can really slow things down when you have a table with 80 columns in it. Remove unused fields, just like I said. And tall tables are fine. You just don't want to have tall tables and wide tables at the same time. So when you think about modeling, you can kind of break this down into 3 different categories. We have flattened models for small report data sets. You can get the job done by munging everything into one table. And this is the way that Excel users think. We want to get everything into one table, and that's okay to a point. But when you start managing larger volumes of data, and you need to build models that support more flexibility and maybe to future-proof them, we want to move away from flat models to using relationships. So database developers tend to think about master detail relationships. In the BI world, we want to think about dimensional relationships. Facts in the middle, dimensions on the outside. Series of blog posts about that I can point you to. All right, dimensionalize it. There's a process for this. Go back to the Data Warehouse Toolkit, maybe a newer book like the Agile Data Warehouse Developer Guide from Lawrence Core. There are a lot of good books on dimensional design. And it all starts by understanding the business requirements in business language, interfacing with business stakeholders, not technical people. So when they're saying, oh, I want to see shipments by carrier at the week level, well, that tells us that we need to create a fact table that stores shipment details at a certain grain related to these different dimensions, etc. Okay. So I'm going to jump back and just catch a topic that I've mentioned, but I didn't demonstrate earlier, and that is using date range filters. So if we jump back to Power Query, you can see that as I was transforming this table, and the thing that actually broke query folding was that I need to have a date type or a date time type column to be able to filter this table on a range of dates. And the reason for that is that that's a requirement to implement incremental refresh. So per the requirements, per Microsoft's documented requirements to implement the incremental refresh feature, I have to have a date time column type. Well, I already have this date, which is my I believe it's my sale date. What I did is I just made a copy of that column and I changed the data type so that it was date time. Why is that a requirement? It just is. That's just the way that they decided to design this thing. Then I create a parameter, which is also a date time type called range start, and another one called range end. Then in my fact table, let me refresh that so it doesn't complain anymore. This was an old error that was the result of my IP address changing on my desktop. Since I'm presenting to you from a motorhome where I use a cellular router, my IP address rotates every few days. And so I have to go poke holes in the firewall rules within my Azure tenant in order to get data through from Azure SQL. So you can see here that I created this derived column and then I added a filter step. We can ignore that error because it's not real. Just clicking on the gear, you can see that I've just created a very simple filter that says, I only want to include records where this partition key, that's essentially my order, my sales date, is after or equal to my range start parameter and is before my range end parameter. Again, if you go look at the documentation for incremental refresh, it will walk you through doing exactly this. Now, what does that accomplish? Let's say that I'm not working in a premium tenant. I'm not planning to import more than, let's say, a couple million fact rows at most. And so I really don't need to partition my table and make it, truly enterprise ready. Well, using this part of that feature, just being able to filter my table using a range of dates, gives me the ability to reduce my working set so that when I process this table, it's not going to take as long. You can see that in this case, I'm actually importing 3 years worth of data. See, my range start is 1/1/2020. Range end is 2023. So it's 3 years worth of data because that would not include 2023. It's before that. But I could go change my range end and say, oh, let's just set that to 6 months. So we'll do 7/1 of 2020. So I'm only going to import 6 months worth of data. Doesn't take very long to process the query. My PBIX file is going to be much smaller because I'm only importing, let's say, a few 100,000 rows. I'm able to test my model. I'm able to visualize and build my reports. Everything works fine. Then I deploy this PBIX up into the service, go up in the service, change these parameters to include, let's say, 5 years worth of data. Now I have all of my data loaded up into the service. I only had to deploy, let's say a 50 megabyte file, and, everybody's happy. So now I'm able to use my GitHub repo to store multiple copies of my PBIX file. I can implement version control. Life is good, even if I don't need to implement incremental refresh. Since I'm on the topic, there'll be a slide on this later. I'm going to jump over and show you where you can implement incremental refresh now. And we do that once we've set up those parameters, as I just demonstrated. We'll go to my fact table. See, that was store sales. Now I'm going to get a warning here that my query may have broken query folding, but that's okay. All right. So you ignore this warning. And what I'm doing is I'm saying, all right, when this table is processed, my store sales table, I want the Power BI service to go figure out how to partition this table so that I can bring in 5 years worth of data. So whatever the date is today, go back 5 whole years and partition this data. So what this is actually going to do is, since I'm incrementally refreshing the last 12 months, I'm going to get 12 monthly partitions plus 4 additional yearly partitions. And after I've processed all of that data, after I schedule my refresh, it is not going to go back and rerun these earlier partitions. There's no reason to. I've archived that data. I have a copy in memory in my model. The data is partitioned. So when I refresh, it's smart enough to only refresh the last 12 months. Now, additionally, I could say go detect changes. Now I need to have a last date of update column in my table in order to do that, which I don't happen to have in this particular table. But if I had an update date time column and I said, okay, detect changes, point to that column, when that column gets updated, when a record is updated in the source, then the Power BI service is smart enough to say, oh gosh, this record 3 months ago, that belongs in that 3-month-old partition has actually been updated. Refresh that old partition as well as the most recent partitions. Now, incremental refresh is actually supported without a premium license, but only up to a model that's 1 GB in size. In premium, of course, you can have much larger models, and of course, they support incremental refresh. Any questions so far about any of the topics that I've talked about yet? And I see that we do have some questions, and Mark, help me out if there are earlier questions. So Jesse, since you're on modeling many-to-many, are you in the use a bridge table and bidirectional filtering camp, or use many-to-many relationship options? I am very much in the use a bridge table camp. I have not had real good results with many-to-many relationships. What I mean is the actual many-to-many relationship type in Power BI. This advice also comes from experts who often talk about this. Marco Russo typically has a lot to say on this particular topic. Not a fan of the many-to-many relationship type, so definitely in the first camp. Let's see, let me read the rest of your question now. Oh, look at that, you're even referring to the Italians here. Yep, totally agree. And before we had the many-to-many type, I did it the old way, and I found no convincing reason to embrace the new functionality. I think it's easier to manage using a bridge table. Any other questions? I think that was it. Okay. As we move from self-service to enterprise scale BI, another important transition is going to be to separate reports from data models. Putting that in BI speak, separating our deployed reports from the published data set in the Power BI service. There are a few reasons for this. One is that enterprise scale solutions tend to have multiple reports. that use shared data sets. Those might be promoted or certified data sets. But regardless, we want to build one data set that is flexible enough to support a number of different reports. So, you know, we're going to end up creating multiple reports, and each of those reports are going to be what we call thin reports. In other words, it's a report that is connected to a published data set rather than the data set living in the same PBIX file. Power BI does that anyway. If you author everything in a single PBIX file, when you deploy that, it breaks it into two different objects. They both happen to have the same name, but they are in fact a data set, i.e. queries and data model, and then reports in another object. Another good reason for the separation is that if you have a lot of work to do, then you can have one developer doing the data modeling work and another developer creating one or more reports. And you know, so we can work in parallel. So how do we do that? How do we make that a reality? It is far more convenient to build and manage everything in a single PBIX file. That's why Power BI was built that way. So let's actually open up. My examples right now are a split model. You can see that there are no reports in this model at all. And then I have a thin report over here, which does not have a model. So you only see two icons here. I don't see my my tables view because this report is in fact connected to a published data set. But if I open up, let me do this from Power BI Desktop. And the reason that I'm opening from the file menu in Power BI Desktop is that I have both the Power BI report server version of Desktop as well as the current service-based version. And because I had installed the Power BI report server version of Power BI Desktop later than the other, when I double click on a PBIX file, it opens it in that version. It's a very confusing thing, but I am going to open up this file. It just occurred to me that to demonstrate what I wanted to show you, I actually don't need to open up the PBIX file. In fact, I'll let that open in the background just to save us some time. But I'm going to go over to external tools. Now, you'll see that I have a number of items on this ribbon. Microsoft embraces community-developed extensions and tools. It's part of their culture. It's really kind of part of the Microsoft data platform ecosystem to encourage third parties to develop add-ons. Now, does Microsoft officially support these external tools? No, they didn't develop them, so they can't guarantee that you know, they can support them. However, and I'm going to minimize this since I'm switching gears on you here a little bit. Because the community has stepped in and have created tools for the purpose of enabling enterprise features, that means that the Power BI product team doesn't have to work quite so hard to support some enterprise features. So, for example, Tabular Editor, and you can see that I have both the free version, Tabular Editor 2, and the pay-for version, Tabular Editor 3, installed. Enables a number of features that Microsoft doesn't support in Power BI Desktop, such as partition management and perspectives. Another set of external tools that you can download from the Power BI Tips site, this is powerbi.tips, it's run by our good friend Mike Carlo, is the hot swap connections and split PBIX file extensions. These are actually developed by Steve Campbell, another MVP from England. And what I'm going to do here is I'm going to split an existing PBIX file into data model and report, 2 different files. It's just magical, it just works. So I have sitting out in my project folder, so I will pull down to my shared desktop, a copy of my single PBIX file project. I want to show you the file size over here. So you can see that just with my demo data, that's about 3.5 megabytes. A single PBIX file. It's got queries, my model, and my report, all in one PBIX. Now, I want to separate the data model from the report. So I'm going to come over here, I'm going to click Split PBIX. You can see that it actually is running some PowerShell in the background. I'm just going to point to that file, click Open, and our work is actually done. So if I jump back to that window, as soon as the progress bar finishes, you will see that I now have a model file and I have a report file. Oops, model file. I'm looking at the zip extension. I'm thinking that maybe it's not quite done. Anyway, let's jump up here to my earlier example, model file, report file. If I open up the model file, which you've already seen, you'll see that there are no reports in it. And if I open up the report file, which, yep, it just renamed the zip extension. Took a little time to do that. All right, I'm going to go open that up now in desktop. Okay, there's my report file. We will immediately see something alarming. So I have all of these visuals that were once connected to an embedded data model. And as soon as this opens up, you'll see that they're all broken. So it looks like something's wrong. Well, the reason that they're all broken is because there is no data model anymore. So I have to connect this up to my data model. Since I've previously deployed a copy of that data model or data set out to the service, I can go to Get Data. I can choose Power BI data sets. Since I'm logged into my Power BI service, I can just go down to my workspace. There's my model right there. Let me make sure I'm connecting to the right workspace. There's my dev workspace. We'll connect to this model. And just like magic, everything starts working. So it really is that simple. Now, the caveat here is that now that I'm working in a separate report file and a separate model file, let's say that I go to add a new report page, I have a new set of requirements, and I realize that I need to go create a measure. And I'm going to create my measure back in my model. So this means that I have to go back to the model file, go write the DAX, debug the measure, make sure that it's working, test it real quick, then deploy a copy of that model back up to the service, overwrite the previous data set, and then I would see the measure in my field list. So there's a little more rigor. It takes a little more work to do that once you've separated the files, but it means that one person can do the model development and another person can do the report development. Let me know if you have any questions about that. Looks like we've had a number of questions come up since we looked at the chat window last. So let me just jump up here.
That's right. There's a couple that are looking at what you were discussing a bit earlier on the incremental, and then a couple current questions as well.
Yes. Okay. So Ryan, you mentioned setting a 6-month range date parameter in the report. I may have misheard you. Okay. So let me walk through that scenario quickly. My goal in using the the date range parameters is twofold. One is I want to keep the working set of data in my PBIX file on my desktop small and manageable. My rule of thumb is I try to keep my PBIX files to 100 megabytes or smaller. And on a slow internet connection, publishing a 400, 500, 600 megabyte file is going to take a long time. It's cumbersome. It will also use up a lot of memory on my desktop. Power BI desktop will use as much memory as you have available. Everything runs in memory. That's why it's fast, but it uses up a lot of memory. And right now, just doing this demonstration, if I go to Task Manager, I probably have 5 or 6 PBIX files open right now. And that's not a good place to be if I'm importing a lot of data. So one, I want to keep that working set as small as possible. But so let's say that I do set that range to 6 months just to keep my working set small. Tested everything, it's working great. I then deploy the model up to the service. In the service, this is easy to demonstrate. I can find the right window. In the service, I can jump over to my data set right here, go to settings. Now, if I've set up incremental refresh, okay, which I haven't done with all of the tables in this model, if I've set up incremental refresh, the service actually takes these parameters away from me so that I can't change them. But here I can go change those parameters. So this is where I would set them to, in my example, 5 years to import all of the data that I need for production reporting. So hopefully that clears that up. What's the best practice connecting to Salesforce data and getting hourly updates? Good question. The Salesforce API is known to be slow and cumbersome to work with. And I would defer to this to one of my colleagues who's done a lot of that work, but I'm not the guy to talk about that. What we've done, actually, in the big project that I'm working on right now with a client, we've actually done that work. I don't know if it was done in ADF or in Databricks, but we are using their connector to stage that data and bring it into a data lake. And then in Power BI, we're connecting to that data. So we're not connecting to Salesforce directly. All right, thank you, Mark. Splitting the PBIX. Okay, good enough. Awesome, thanks for the feedback. Does a report file have to have a PBIT extension? No. So a PBIT is a template. Templates don't have any data in them, and a template could either be a thin report or it could be a model that doesn't have any data in it. Separate concept altogether, though templates have some value. That's not related to what I'm demonstrating. Yep, and Elena, definitely agree with your comment there. What's the best practice in using a single data set for multiple reports in different workspaces? This can be a little challenging. You can certainly connect to a data set across workspaces, but there are some security implications. And that also doesn't work with deployment pipelines, which is what I'm going to show you next. So I'm going to give the consulting answer and say it depends. You can have one central shared data set, but then there are some features that become a little challenging when you do that. So depending on your needs, you might need to publish multiple copies of the data set. When would you use Azure Analysis Services? Bob, my answer is only when I have to. So Power BI in premium capacity is quickly displacing Azure Analysis Services. Microsoft will not ever tell you to stop using a product that is profitable for them. And I think that that's one reason that they're not telling their customers to stop using AAS and to use premium data sets instead. There are still features in AAS that are not quite as easy to get to in Power BI. However, if we turn the equation around, there are far more features and capabilities that exist in Power BI data sets that do not exist, nor will they likely add to Azure Analysis Services, like Incremental Refresh, for example. And Jesse, do you feel the XML enhanced functionality will still steer people to design models in Visual Studio again? I did a blog post a couple of years ago where I said some very bold things about how I refuse to use Visual Studio for tabular model design anymore. I don't know. I think that there's always going to be this volley back and forth between using Visual Studio and desktop with Tabular Editor. My reference point for making that decision is the folks that I know on the product team. And I don't want to throw anybody under the bus here, but as I talk to folks like Christian Wade, for example, on the Power BI engine team, the advice that I continue to hear over and over again is use desktop to start building your models, enhance it with tools like DAX Studio and Tabular Editor, and that's the sweet spot. That's where the goodness is. If you pay attention to professionals like the Italians, and I was just going to say, Chris Webb, even though he works for Microsoft now, was definitely a thought leader in that camp. We've all kind of gotten away from using Visual Studio. So, are we going to come back? I don't know. I'll kind of close out this soapbox speech by saying that the Visual Studio product team is not incented to enhance their product to support BI as much as the Power BI product team are incented to continue to evolve their tools to support enterprise BI. So it's a complex topic. All right, let's get back to our presentation. So enterprise scale options. I have talked through this slide, so this is for reference, kind of bringing this all in one place. I will just restate that using this parameter approach, this is something I do in practically all of my projects now, whether or not I plan to use incremental refresh, simply because I can control the size of the PBIX file, which is very, very important, especially when you're dealing with data volumes that would make your PBIX larger than 100 megabytes in size. Incremental refresh is icing on the cake. It's a capability that you get by doing this. All right, so use parameters to filter your results. All right, calculations and measures. Again, the database developer is going to prefer to do calculations in SQL. An important lesson for someone coming from that mindset is to understand the concept of context. And there are different types of context that we think about as you're interacting with a tabular model in a report. And that is, filter context, row context, when you slice, when you group, when you filter. Calculations are performed interactively. And if we're relying on data either stored in a SQL Server database that's pre-aggregated, you have to think ahead and you have to think about what are all the contexts of those calculations? How do I store my data so that if I was reporting at the month level, I can then go down to the date level? It's hard to store data with all of those requirements in mind and those requirements that might change. Whereas DAX is a language that is context driven. Measures exist for the sake of quickly recalculating and performing calculations on the fly as the user is interacting with that data, as they group, filter, and slice data in different ways. So very, very important concept to understand. So again, the BI solution developer is going to use DAX because that's what this language is all about, and pay attention to context within the report context. And there's a balancing act there. So you might want to err on the side of storing data at a more granular level than your requirements might call for without going overboard, without paying a high cost for that. If models are designed lean and mean, we can easily store tens of millions of rows of fact data. And in larger, more enterprise scale models, we can store hundreds of millions, even billions of rows of fact data within a Power BI model. Premium capacity to manage models that big, but we can handle it if you design it right. Okay, I'm going to skip over this topic and get to this topic right here. Not that security is not important. I just want to be mindful of our time. How do we manage deployments? How do we gate the introduction of new features and new capabilities that could destabilize a solution? The database developer is going to think in terms of rigid development lifecycle. So I have a development sandbox. I can experiment to some degree there, but anything that I build, anything that I create has got to be checked in. It has to be scriptable. It has to be automated. It has to be backed by a requirement. If a stakeholder, a user says, hey, can you go add this column or add this calculation? Well, yeah, give us a change request for that. Let's document that. Let's manage it. That tends to lead to long release cycles. This is why we don't let developers sit with users, because they tend to just give them what they want. However, in the BI world, we do tend to do that. We sit down with the business stakeholder and say, all right, what do you want? Let's go create it. And then we'll deploy it, and then we're done. But it can be messy, undisciplined, and it can be chaotic. And then we may end up with models that we have to throw away and start over again. So the meeting in the middle is that we have to right size the process for the audience. And there is no silver bullet solution to meet this need. There is no always do this and it will always work. But we can separate our enterprise solutions, which are going to kind of lean toward the side of the spectrum that is very disciplined and rigid and takes a long time to deliver solutions, to we'll separate those solutions from self-service models. Now we can build an enterprise model and then let users go create their own reports. And if properly supported and trained, then users can use Analyze in Excel to use Excel connected to a certified data set. They can use Power BI Desktop to do that. There are other third-party tools that they could use as well. But we want to sandbox the stuff that is unofficial. So create a workspace for that. And that's less trustworthy, more ad hoc stuff, and that's okay. So apply rigid controls to certified models and even certified reports. I'm working with a client right now where we are branding our reports with, this report is based on a certified data set. This report was created and certified by our IT group, known to be completely accurate. And so, we have some governance rules on those things, as opposed to giving users the freedom to create whatever they want with the understanding that there's some risk. Okay, so let's talk about deployment pipeline. So This is Microsoft's answer to managing progressive releases with Power BI. We've had deployment pipelines for, going on 2 years from now, but we've recently seen some enhancements that will make this even more and more attractive as we go into the future. So let me just give you a quick demonstration of how deployment pipelines work, and then we can talk about what to expect later on this year. So a deployment pipeline, this is a premium feature, by the way, so I'll just set expectations with that. Now, I have a premium per user license. We are not in a premium capacity tenant. So, even though I do get some free stuff from Microsoft through the MVP program, that doesn't mean that I can just set up a premium capacity tenant and then share out reports and data sets with lots of other people. But just using my premium per user license, I have 3 separate workspaces that are part of a deployment pipeline. Now, you can do one of 2 things to set up a deployment pipeline. Go create a workspace, and then within that workspace, there's a button up here to create a pipeline, and it will say, all right, we're going to create a dev workspace, a test workspace, and a production workspace. So the workspace that you started with, what is that? Is that your dev workspace? Or you can go create a pipeline and then add workspaces to it. So either way, it's an easy thing to do. So as you see, here's my pipeline called Contoso BI Solution, and it consists of a workspace called Contoso BI Analytics Dev, a workspace postfixed with test, and I don't need my users to see that I'm using deployment pipelines, so I'm not going to put prod at the end of this one. But you can see that all 3 of these are premium workspaces. See the little diamond there, the little user guy tells me that was created using a premium per user license. But I simply deploy from desktop out to this workspace. Okay, so that's just a normal workspace. It behaves like any other workspace. Now, let's go back. Now, I just want to point out, if we go back to my desktop file, bunch of these open, so let me get to the right file. If we go to Power Query, I want to show you that my database name, which I'm using a parameter for, this is the dev instance of my Azure SQL database. Okay, so I have two databases again. I have Contoso DW-dev and I have Contoso DW. I'm going to manage my database separately from Power BI. And because I only have 2 databases, I want to point dev to dev, I want to point test to prod, and I want to point prod to prod. And I have a parameter for that. So now I'm going to go back to the deployment pipeline. So after I've deployed some stuff, I've got 1 data set and 2 reports here. Then I'm going to click the deploy to test, and that's going to make copies of all of those objects. And I can select individual objects if I want down here and show more. Show less. All right, so now I have a copy of all of my objects here. So I'm going to go to, let me just go here and just show you again that I have 1 data set. And that data set by default is just going to be an exact copy of my dev copy. But I'm going to add a deployment rule on the data set. So we go to this data set and we say, all right, when I deploy to this workspace within my deployment pipeline, I want to change the database name parameter from Contoso DW-dev to Contoso DW, my prod instance or my prod database. Okay, and that happens when I deploy. So if I make that change, it's not going to immediately apply it. I have to go to deploy a new copy. And that just magically works. And if I reprocess this, if I were, to make a change in my production instance only, we would see that in this data set. Here you can see that this version of those three objects is exactly the same as that version of those three objects, with the exception of that parameter that I've changed, because I have a little green checkbox there. And then same thing with production. If we were to look at that rule, we would see that I have the same rule. So this is awesome, just as it is, just having this ability to gate these things. Working with a big enterprise client right now, we actually have a team of QA folks who, as I'm making changes, I'm pushing out to dev, but once I've hardened copies of my reports and data sets, I will deploy to test. My QA person knows that that's a testable version of the data model and reports, and I'm not going to push a new version until those new features are ready so that they can test them. Once they sign off, then we may go through some debugging cycles and and push some updates, and then I'm going to deploy to production. Now, what to expect in the future? There is an API that will interface with Azure DevOps. It's a little immature right now. I played with it a couple of months ago, didn't have a real good experience. It's been updated. It will continue to be updated. The roadmap says that should likely go to GA later in 2022. And what that means is that we can orchestrate this pipeline and our build from Azure DevOps, and the whole thing can be scripted. It can be done with PowerShell. It can be done with whatever tool you want.